I'm sorry I'm not in Jamaica or anywhere fabulous. I am simply at home very early in the morning getting ready to um, work through some characteristics of exponential functions for you. Characteristics have been a source of some frustration as we've worked through the course because I think we've been throwing a lot of information in all at once. So what I'm going to do this time, this last time with this last kind of function is I'm going to break it up into a lot of really short videos, and hopefully that'll make it a bit easier for you to go back and look at specifically the domain and range of an exponential function, or specifically the interval of increase and decrease. So you are going to need to watch all the videos, but I'm going to do my absolute best to make them short and concise and really get the point across the first time. So let's get to it. All right, lesson 4.3 is on characteristics of exponential functions. Our learning target is that we can identify and interpret characteristics of exponential functions. So as I've said before, this is the third kind of function we've looked at. So there are going to be some similarities to linear and quadratic functions. There are also going to be some differences and some things that are unique to exponential functions. So we're going to go through some each of them individually, like I said in the intro, just short little videos. Most of the vocabulary is going to be familiar, so I'm not going to go over the vocabulary in detail, but if you need to refresh yourself, you can always go back and look at that glossary or previous videos. There's only one characteristic that's new and unique to exponentials, and that's the asymptote. We've talked about it a little bit as you were graphing it, so I'm going to try and go into more detail with that for you in one of these videos. We are kind of like we did with quadratics. We're going to use two examples for all of the characteristics. If I can go to the next page, I will show you those two examples. Oh, no, we went too far. All right, so we're going to use these two examples on each set of characteristics, and I've put them in your packet multiple times so that you don't have to flip back and forth. And so we're going to start with in behavior. In behavior, just like previously, is a way of describing what happens to the output of a function as the input approaches, or the x values approach negative or positive infinity. So the way you will see that written, there's actually a couple different ways. The way I tend to write it, and therefore the way it shows up in your packets, is this set of symbology where it says as x approaches infinity, y approaches what? So what that means is as you go to the right, as x gets bigger and bigger, what is y doing? Well, with this graph, as x gets bigger and bigger, this thing is climbing very rapidly, which means y is also approaching positive infinity. The other half of this is as x approaches negative infinity, meaning as I go to the left, y is approaching what? Well, we're used to putting infinities in behavior, and here's where something is a bit different with exponentials. This line, or this graph, is going down as I go towards negative infinity, but it's not approaching negative infinity. Instead, what it's approaching is that asymptote. It's getting closer and closer to that x-axis, which means the y value is getting closer to 0. Okay, so on these in behaviors of exponential functions, one of them is going to be an infinity sign. One of them, though, is going to be the value of your asymptote. So that asymptote plays a really huge role in most of the discussion that we have with exponential functions. Another way you will see it written sometimes is instead of writing these symbols, it'll say as x increases, y decreases or approaches 0, or whatever, y does something. So and sometimes you'll even see f of x there because we know those are interchangeable. But so know that you might see it that way, but it means the same thing as x approaches positive infinity, because that's obviously it increasing. Okay, the second example is this function right here. There should be arrows there because it is continuing on. And this time as x approaches positive infinity, I am approaching this y value of 4. I'm getting closer and closer to that value of 4. I'm never actually touching it. So that is what y is approaching. As x approaches negative infinity, so as x decreases and I get smaller and smaller, now I'm pointing down and I'm trying to get to negative infinity. So again, one of them went to an infinity, either positive or negative. The other one is just approaching some value, that asymptote there. All right, what I want you to do now is go ahead and move on to the next video, and we will talk more in depth about those asymptotes.